Seven basketball players are sitting on a team bench. So if you're sitting them down, you're looking at them, you're arranging them, right? I wouldn't even have to write arrangements. How many arrangements are there if two forwards always sit together? So we have 7. So I have to sit the two forwards together. So I'm going to go 2, then 1, then 5, 4, 3, 2, 1 times what? What do we do? 5. Times by 6. Yeah. Because it's one more than that number held together, because if there's 5 objects, we have 1, 2, 3, 4, 5, 6 spots to put it, right? So it's always one more than the number after the hook together, which is 6. So I get 1440. Then I have, how many arrangements are there of the word Jacob if the vowels must be together? The moment I get a word, I write it out. J-A-C-O-B. And if I just rewrite the word, that's cool. It means I have no denominator, right? I have no double ups, no triple ups, no having to deal with all of that and get rid of it by factorials. Now it says the vowels must be kept together. 1, 2, 3, 4, 5. How many vowels are there? 2, the A and the O. So I hook them together at the front, and I get 2 and then 1. Then how many do I have left? 3, 2, 1, and am I done? No. If it says vowels together at the front, would I be done? Yeah. But it doesn't, so I have to still multiply by 4. I can move between those spaces, so I get 48. Now here it says, how many arrangements are there of the word Calgary if the vowels must be kept together? So C-A-L-G-A-R-Y. When you get to words, there are a few things you have to look for. You have to look for if there's doubling or tripling of letters. You also have to look for if they're arranging all of the letters, or 4 of the letters, or 5 of the letters, because sometimes you guys get in a pattern of you've seen enough questions that you don't read the whole thing, and you just assume you know what I'm asking, and you'll find all the letters, and it'll have actually asked for 4 of the letters. And will they have the answer to all the letters there if I ask for 4? Yep. And you'll pick it. You won't even notice that you got it wrong because you skipped over the word. So you always read all of the words, right? No skipping, no assuming that it's the same as something else you've done before. Always go through and read everything and make sure you catch all of the little things. Okay, so I know 2 factorial on the bottom because of the 2 A's. And now I read it. It says, if the vowels must be kept together. Calgary has 7 letters. 4, 5, 6, 7. It has 2 vowels, the 2 A's. I treat them like they're different because the 2 factorial gets rid of the cases where they're not. And then 5, 4, 3, 2, 1 times 6, because it doesn't say together at the front. So it's going to be 720. Then I have, what are the number of balanced meals that you can have a choice of 7 meats, 4 carbohydrates, and 5 vegetables? And I told you as long as you choose one of each, you can do the blanks. You're indirectly, the blanks, the fundamental counting principle only works for this one because you're choosing one. And I'll show you why, because this is actually a combination. So, 7 meats, 4 carbohydrates, 5 vegetables gets you the answer of 140, which is true. But what you're actually doing is if I picked 2 meats and I made a balanced meal, would it matter the order in which I picked those 2 meats? Would the order matter? No, it's actually a combination. What you're doing is you're going like this. 7C1 times 4C1 times 5C1. But the blanks work because 7C1 is 7, 4C1 is 4, 5C1 is 5, and that's the only reason why the blanks work. But say I was actually picking 2 carbohydrates instead. Well, this is the caveat, it's not exactly like this. If I pick 2 carbohydrates, I would have to go 7C1 times 4C2 times 5C1. Same thing with menus. When you do menus, remember I told you if you had appetizer, main course, dessert, and I told you you could pick one of each, you would just multiply the numbers of options. But if you could pick 2 appetizers from 4, then I told you there's another way you'd have to do it. You'd have to use combination. So you'd go 4C2 times main courses, 6C1 times desserts, 7C1, whatever it may be. You have to use C's because they actually are combinations when you do this. So when you're picking outfits, remember how we were talking about the person who was, I think they were airplane stewardess or whatever, and they picked 1 pair of pants, 1 shirt, and 1 blazer or something. I told you if they picked 2 pair of pants, you couldn't do it that way. You'd have to do the C2. Okay? Now here there are different ways, there are two different ways that phone numbers in Okotoks may begin, either 938 or 995. So that is two options for that first spot. And then 4 digits to follow. It can be anything else. 0 to 9. So that's 20,000. If we still only had landlines, we wouldn't have enough numbers. But because these are the landline numbers, I don't think we're ever going to run out of 20,000 landlines, even if we have 30,000 people. Because most people, who in your house has a landline? Who in your house? Oh my gosh. Who in here has a house with a landline? Yeah, so under 50. So we'd have to reach like 60,000 people to probably run out of landlines. If it were up to me, I would have a landline, but it's up to my husband, so we don't have a landline. So I'd like my kids to be able to call with it, but we don't. So they have to Facebook message us. All right. How many 5-card hands? So no matter what, every case has to have 5 cards, right? 5 cards. Oh, great. So how many 5-card hands must be dealt to have 2 face cards? So I know that it's cards, so I know it's a combination. I know I want to choose 2 because that's what it tells me. I know I want face cards, so I have to choose from face cards. How many face cards are there? 12. And then people will give me that answer, right? And I know this answer will come up on the test, and people will pick it. But remember, you have to read and underline. So I want 5-card hands. Currently, I have a 2-card hand. So I know I need 3 more cards, right? That will get me 5. I know that. I know that they cannot be face cards because I'm only allowed to have 2 face cards. So I have to do what? 52 minus the 12 face cards off of it. Because these 3 have to be 3 not face cards. They can be anything else, but they're not allowed to be face cards. So how many are there that are not face cards out of 52? 40. And what should these 2 add up to technically? 52, right? Because they should be opposites. And then that would get you that number. And when in Rome, we're going to just do the other one because it kind of runs with it. This one wants at least, so it's still 5-card hands. And you have to read because sometimes it could be a 6-card hand. I just hit that with my hair. It could be a 6-card hand, or it could be a 4-card hand, or 3. Like they can make whatever card game they want out of whatever card deck they want. So please don't assume it's 5 cards. Okay? Always read. So 5-card hands must be dealt from a standard deck that has at least 3 black. So I have to have at least 3. So if I went to a store and I needed at least $3, I would need $3 or more, right? And in this case, I need 5 cards, so I'm going to stop at 5. So I need 3 black cards, or, and this would be the case, 4 black cards, or 5 black cards. And then this would be times 2. And then it would be not black. In this case, black is the opposite of red, so we can just say red. But we could just say not black as well, right? And then that last one doesn't need any supplement because it has 5 cards. So then we do half the deck is black, so 26C3, half the deck is red, 26C2, plus 26C4, C4, times 26C1, plus 26C5. Do you think I'll have an at least or at most case in on my test? Yeah. It might be cards, it might be people. Like I might be making a subcommittee and it has to have at least 2 principals on it or something like that. You will have an at least or at most, for sure. You absolutely will. Because it's a curriculum outcome I have to cover. So I'm going to have to test it. Okay? You guys try these ones out. Don't do this one or this one. It's binomial. If you get past this assignment, you hit the next one. The answers to the next one are at the very back of the booklet. Quickly, because it's one that's stumping a few people. So here it says, how many 3-person special math committees can be formed from a class of 20 students if the person with the highest average must be on the committee? Does this committee have jobs? No, so it's a combination. We know that. The committee does not have jobs, doesn't stipulate anything different. However, it does say that that person with the highest average must be on the committee. So we have to do that first. So how many people with the highest average are there? And I'm going to choose them. Then what do I have left? 19. Choose 2. So remember we talked about these ones, the 7 teams in the league. Each team must play each other team twice, once at home, once away. How many season games are there? So It says there's two ways because we can go 7. I have 7 teams. I choose 2 at once, right? Now, the catch on this is I have to times it by 2 because they play 2 games, and that gets me 42. Now, some people use 7p2. 7p2 only works if they play 2 games because it treats it like there's order, so it gives it a home and away. So if they play 2 games, you could just go 7p2 and you'll get the same answer. But if they play 3 games, you'd actually have to like go 7p2 times 2, take off half of that because they can't play an odd amount of games. With 7p2, it's a lot more complicated. So I like 7c2 better because it makes them play 1 game. And then if they play each other 5 times, I'll just times it by 5. If they play each other 8 times, I times it by 8. It just makes it a lot less painful. Now, can you grab out a separate sheet of paper? I want you to try something. So I'm going to have in a league every team plays each other 3 times. I'll say that this is intense. We're going to say that this is a really large baseball league. Baseball. There's quite a few games. In a league, every team plays each other 3 times. They play a total of 315 games. What am I going to ask? How many teams are in the league? Can we do any guessing and checking? Is this a written response? No. You have to use the formula sheet. Try that one out. Okay. So this one here says in a league, every team plays each other 3 times. It's baseball. So how many teams play? I'm going to dance really quick. How many teams play each other in baseball? How many play at a time? 2. So we know we're going to choose 2 to play at a time. From N, I don't know. And now, remember when they played 3 times last time, we times it by 3, or if they played 4 times, we times it by 4. That does not go in that second spot, right? We have to, if it's baseball, hockey, soccer, any of those, we're choosing 2 because 2 teams play at a time. Think about it with handshakes. When we shook hands, we chose 2 because 2 handshakes happen at a time, right? Please don't put a 3 in that spot. I set you up, just so you know, because that's what happens all the time. And then math doesn't math. Okay, so then we times it by 3, and we get 315. Then what's my first thing I do? Divide it by 3. And I get NC2 equals what? Yep.
This is 315. I thought I said 3 out of 5.
315?
I thought I said 3 out of 5. How's that going to work?
Oh, good luck if you have that ever given to you. I don't know how they play 3 out of 5.
Times 3 by 3.
Okay. And then we do the formula. So we get n factorial over n minus, not r, n minus 2 factorial, 2 factorial equals 105. Then what do? Times it by the 2. So I get n factorial over n minus 2 factorial equals 210. And then I expand like we did the other one. n minus 1, n minus 2 factorial over n minus 2 factorial equals 210. And I get n squared minus n minus 210 equals 0. What multiplies to give me negative 2, 10, and adds to give me negative 1. Negative 15 and 14. So n equals 15. That's the number of teams. N equals negative 14. Does that make sense in this question? Negative 14 teams? No. There are 15 teams in the league. Try this one. Or I get this. 4p2, 5p2. So, or I get 4 times 3 times 5 times 4 times 3. These are actually the exact same. Both still wrong. So both those answers are wrong. This one's close. This one's kind of like halfway there. That one's just terribly wrong. Okay. Why is it wrong? If I do this, it is a word, so it is a permutation. I get that. I totally understand why you went that way. I totally understand why everyone goes this way. I totally understand why you're getting it wrong, because I haven't shown it to you before. Just wanted to see what you do. Okay. So if I do 4p2, 5p2, that's the same as this down here, right? That means I'm only ever rearranging the 2 letters in pork and rearranging the 3 letters in stage, but I'm never intermingling them, right? So if I had O and K, I would have KO or OK, and then I would have STA or TAS, but I'm never ever intermingling them and making a word, correct? So that's not going to work. If I choose the 2 and choose the 3, then they're never ever joined. There's words that will be formed when I pick the 2 together, right? So this way does not work. This is halfway right. We're halfway there. So 4C2, 5C3 just gets me to choose the letters, correct? So what 2 letters am I choosing from pork? Give me them.
O, R.
O and R. O is on one word, letter page, R. Okay? So all 4C2 does is gets me 2 letters, right? Now I have 2 letters. Cool. 5C3, what 3 letters do I want from stage?
A-G.
Oh, I was like H. At first I heard H. I was like, there is no H in stage, no matter how you spell it. G-E. Okay, cool. So on these 3 pieces of paper, I have A-G-E, and that's how I just got these 3 now, right? That's what 5C3 does. It gets me these 3. 4C2 gets me these 2. And then people who tell me that's the answer, you now have this. Is this even a word? I have all of them stacked on top of each other. Is this even a word? I can do this with them. Am I forming any words?
No.
No. So, cool. This got me the letters. Now I have what? I have how many? I have 5 letters. What do I still need to do with them? Put them into a word. How do I do that? 5 times 4 times 3 times 2 times 1. It's a perm-com mix. You have to do a combination first to get the letters. Then, now I have them, I have to arrange them. Get them, then arrange them. Okay? The C's get the letters, now I have them. Now I have 5 for the first blank, leave 1 behind. 4 for the next blank, leave 1 behind. 3 for the next blank, leave 1 behind. 2 for the next blank, leave 1 behind, put the E at the end. Right? So the C's get me the letters. And I have to do the C's. I have to do the C's first. I can't go directly to the P's, because if I go directly to the P's, I'm never intermingling the letters from pork and stage, ever. Another example. Okay? I'm going to give you, in the school division, we're going to pretend there are, I don't know how many there are, I kind of stink at this. There are 10 principals. There you go, 10 principals. Which you spell as a pals, because they're your pals, right? Not poles. That is a principle of mathematics. Okay, we have 10 principals and we have 16 vice principals. Yep, in this school division. we have more school division, not in this school. Vice principals. Cool? Okay, we're forming a subcommittee of 2 principals and 4 vice principals. How would I do that? P or a C? NC2 times 16 C4. Everyone's golden with that. That question, everyone can rock it. Then I just change it a little bit and life goes badly. Okay, so I'm making a subcommittee of 2 principals, 4 vice principals, and now we want a yearbook photo of them for the principal, vice principal yearbook. I don't know. And now we want a photo. And then they take a photo. So some people will say, oh, a photo, that's an arrangement. Cool, order matters. So then they give me the answer, 10P2 times 16P4. Does that work? No. That never arranges the principals with the vice principals. It never intermingles them. So I can't do that. So I still do have to do it this way. I have to get my principals from principals. I have to get my vice principals from my vice principals. And then I have to do what?
Times it by 6 factorial.
Times it by 6 factorial. Because now I have to arrange them. This is the exact same as saying pork and sage, right? Choosing letters from them, arranging them. Does that make sense? So sometimes this comes up where they'll go to a family, go take a family photo, and they only want to take 2 of the girls and 3 of the boys, and then they want to arrange them. I don't know, are they the favorites? I'm not quite sure why they're not taking all the children. But they take 2 of the boys, 3 of the girls, and they rearrange them. Well, boys choose 3, number of girls choose 2, and then arrange them 5. It's the same thing, right? If you're picking groups and then you're arranging them, you're picking them and you're lining them up. If you're picking from 2 separate groups and then aligning, arranging, taking a photo, it's a perm mix. Okay? Keep going on your questions.